Let's take a look at this word problem that's really not that difficult. It looks very difficult because there are a lot of words going on here, but we'll break it down and walk you through a few different strategies that you may think about to try to solve this type of problem. So the amount of energy released in an earthquake was 500 times greater than the amount of energy released from another. The equation 10 raised to the x power equals 500 represents the situation where x is going to be the difference in magnitudes on the Richter scale. So they've given us a formula. That's good to note. We want to, to the nearest thousandth, find the difference in magnitudes. So we have 10 to the x equals 500. They've given us an equation. We want to find this difference in magnitudes. That's finding x. So the first strategy you may try to get going is if we can rewrite this as 10 to the x is 10 to another power, then we have the same base on both sides. We're going to be allowed to drop our bases and set the exponents equal to one another. So this is most students' first strategy. We say 10 to the first power is 10, 10 to the second power is going to be 10 times 10 or 100, 10 to the third power is 10 times 10 times 10, 1,000. You may notice that we skipped right over 500. So we're not going to be able to use a nice integer as our new exponent so that we can drop those bases and set the exponents equal. So the next strategy I would try to attempt is, you note that we have 10 to the x power already on one side all by itself. So the exponential part is basically isolated. What we could do is we could apply a log base 10 to both sides. It's a one-to-one function, so that's why we're allowed to do this. But we could say log base 10, and the reason behind that is our base over here is already 10. So log base 10 applied to both sides. Whenever you have this situation where you can use base 10 is already in the exponential part, you can use log base 10 to match up those same bases between the logarithmic and exponential part. These are inverse functions of one another, so you get this very nice canceling out that we're going to be left with x on this side and then log base 10 of 500 on the right-hand side. Now that log base 10 of 500, when the base is 10 for the log, that's a common logarithm, and that's the log button on your calculator. So we can get our approximation here by doing log button and then 500, maybe close some parentheses and press enter. So I got 2.69897. We are asked to round this to the nearest thousandth. So we're going to go tenths, hundredths, thousandths place. We're really looking at this next digit to see if that's 5 or above. It is, so we're going to round our solution up to the nearest thousandth. So 2.699. All right. The other strategy you could utilize on this one is you could use over on the right-hand side, this is the definition of logarithm, or logarithmic function. So from the beginning, we were in exponential form. What you can do is you can kind of go ahead and line up. We're in exponential form. We could switch over to logarithmic form. So to do that, what we want to do is we'd want to start out and go to logarithmic form. We're going to have a log and then identify what the base is going to be. Well, the base is whatever has the exponent on it. So in our case, 10. And then our exponent, and this is a little awkward, but the exponent is going to go on the other side. So the exponent, in our case was x, is going to move over to the other side here. And whatever was on the other side, as we started out was the 500, it's going to go inside the logarithm. So you may note these are the same thing. They're equal. So we'll get the exact same approximation by using our calculator. This way, using the definition of logarithm as we did by applying a common log to both sides to cancel out the base 10. All right, so I hope this helps out. A few different strategies to try to solve these exponential equations. This one happened to be a word problem. Good luck.